I'd like to take a look with you at some examples involving the chain rule. The chain rule is the topic of section 3.7. And of the derivative rules we've learned, this is a fairly challenging one to get used to. I encourage you to definitely look at as many examples as you can, practice. Once you get it, I think you'll find it's an extremely useful rule. It has important applications, and we'll see in section 3.8 and 3.9, the chain rule is at the heart of a couple of additional rules that are coming that will wrap up this chapter 3 material. So what we have here is on 25 and 42, we've got two examples that are good illustrations of the chain rule being used. Okay, so here we have 3x squared plus 7x to the 10th power. When we take the derivative, we're taking the derivative of the outside function, which is what happens if we think of the original function as sort of a two-stage process. The outside function is what happens second. So where we had this raised to the 10th power, now we have 10 times that to the 9th, which looks like the power rule. It really is the power rule that's happening here. And then we multiply that by the derivative of the inside function. Okay, so going back to the rule itself, g prime, the derivative of the inside function, is right here. And here we're taking the derivative of the outside function f, leaving the inside function alone. Now let's look at that same rule in a different example. Here we have sine of 4 cosine z. So if we think of what would we do to z first, we'd find 4 cosine of z, and then we take the sine of that. Okay, so the inside function is 4 cosine z. When we take the derivative of the outside, well, the derivative of sine z would be cosine z. So the derivative of sine 4 cosine z will give us cosine of 4 cosine z times the derivative of the inside, which will be negative 4 sine z. Now, I would just note in wrapping up this example, a word of caution about simplifying. I see oftentimes students will, perhaps take the derivative correctly and then get this impulse that they should simplify, which is understandable, but they will make mistakes in terms of simplifying. So just be careful about that. What I did here was I moved this negative 4 sine z out in front to avoid the potential mistake of, thinking that we should be, multiplying in some other way that would not be correct. All right, let's take a look at 12, which is a little different, but also a good way to kind of understand the chain rule at work in a different way. So here they give us these two functions in graph form. Now these functions happen to be lines, which is going to be important as we go through this. What I want to emphasize is to do this problem, we don't actually need to find the equation for those lines. Okay, we could. Okay, that would be a way of getting the answer here. But I think it's important to be aware that even if these weren't lines, if we had a way of finding certain slopes at particular points, if we had, just the right information, we could find an answer without even knowing what the formula is for the specific functions involved. If we have the right derivative information, the right additional information about points on the graph. Okay, I'll show you what I mean here. So they're asking for h prime of 4, and they've told us that h of x is f of g of x. So the chain rule says that h prime of x will be f prime of g of x times g prime of x. So h prime of 4 will be f prime of g of 4 times g prime of 4. Okay, just substituting in x there. Now g of 4, according to the graph, is 5. And I labeled that point there because it's a little easier to see in the textbook than it is in my sketch there. But now we find that what we're looking for is f prime of 5 times g prime of 4. Okay. So as long as we can determine what f prime of 5 is and g prime of 4, then we can complete this problem. Well, these are lines again, and although we don't need to find the equation for the line, we do need the slopes at these points. And of course, with a line, the slope is the same everywhere. So if we look at this one and do change in y over change in x, I'll just say m equals 5 minus 4 over 4 minus 0. So that has a slope of 1/4. Okay, in this case, we could do, again, change in y over change in x, negative 1/2. Okay, so that's the slope of the 1/4 up here is the slope of the line G. The negative 1/2 is the slope of the line F. And if we go back down here, that's negative 1/2 times 1/4. Those were the values we found. So what that tells us is that h prime of 4, which they were asking us to find, is negative 1/8. Okay, so that's the chain rule in 3 examples. Again, this is a topic that you're going to want to get plenty of practice with, but I hope this helps you in that effort. See you in the next video.